Hello and welcome. In the video, I'll be solving a couple of problems for vertical projectile. And if you're new to the channel, please hit the like and subscribe button to show support. Right, so I request that before we attempt these questions here, you have a formula sheet in front of you, right? Because we will be taking into consideration the formulas, right? So I think let's get straight into the first question here, right? So you have to be familiar with using equations of motions. You have to be familiar with analyzing the situation and try to understand if the object is being projected up or is being projected down. You have to be comfortable with the directions and all these sorts of things, right? And your formulas, right? So let's get straight into the first question here. Question 3. So we'll read the question together, right? So we have question 3 here. An object is projected vertically upwards, right, at 8 meters per second from the roof of a building which is 60 meters high, right? It strikes the balcony below after 4 seconds, right? So the object then bounces off the balcony. So we see that here the object is going to move with some initial velocity, which this initial velocity, it's 8 meters per second, right? So to go all the way up and it reaches the maximum height, so the velocity of the maximum height here, it's 0 meters per second when we analyze the situation. And then according to the information, this object went all the way up and went all the way down, right? So it took 4 seconds. It took 4 seconds for the ball from the point at which it was projected all the way up and to hit the balcony, right? So this is the time that was taken there, which is 4 seconds. So now the object, right? So now the object then bounces off the balcony and strikes the ground. So we can see it bouncing here at the balcony here, and then it's going up again to reach the maximum height, which this maximum velocity here, it's going to be 0 again, right? So it's going to go down and hit the ground, right? And strike the ground according to the information. So now let's get straight into the first question here. 3.1. The asking is the acceleration at which the maximum height is the object's acceleration at its maximum height, upward or downwards. Okay, for if it was the velocity, we would say the velocity at maximum velocity at maximum point here, right? The maximum velocity would have given us 0, which is the velocity at the maximum point. Because they're asking for the acceleration, we have to pay attention to this. So it's asking the object's acceleration at the maximum height. So we know that at the maximum height there, the acceleration is always 9.8 meters per second squared, right? So the acceleration is always that, and the direction is downwards. So throughout a projectile, at every single point of the projectile there, we can see that we always have the acceleration of this going downwards, right? Except for when the object bounces. So as the point where at the point where it bounces, the acceleration is not 9.8. So if you take a look at the acceleration graph, you might have seen that it's always a straight line, and then when we involve bounces, it gets affected. Do you see that? But then the moment the object is on a free fall, we would still see that the acceleration is 9.8, right? So let's not talk about that too much, but let's rather focus on solving these problems. So the direction here would have been downwards, right? So the direction here would have been downwards, and let's go to 3.2, right? So this was saying that we have to calculate the magnitude of the velocity at which the object strikes the balcony, right? So we can see that for this kind of a situation, we have that the initial velocity of the ball is 8 meters per second, right? And they want us to calculate the velocity that it's going to strike the balcony, right? So what is this velocity here that it's going to strike the balcony with, right? So we can see that if this is the initial point, this is going to be the final point. So this is VI, and this is our final point here. So we can select these 2 points and make use of these 2 points for the time being 4 seconds, right? So what is the displacement there? What is the displacement here for the object to move from here to there? We can see that the displacement here to move from here to there, we don't have it, but they want us to calculate just the final velocity, right? So because we have the time, so I think what we can do is we can simply make use of the information that we have, right? So the final velocity here we don't know, but the acceleration we do know, right? So if we decide to take upward as positive and downwards as negative, you would see that your initial velocity is going to be positive, right? Since it's going up, right? So your initial velocity is positive since it's going up. The delta t, it's just 4 seconds, and the acceleration here, since it's going downwards, it's going to be negative 9.8 meters per second squared. So now let's select the formula that is suitable, that we can use to calculate the velocity that it strikes the ground with, right? So we also don't have the displacement, so I think this formula would have helped. Delta t, right? So what is the final velocity here? We can substitute the initial velocity being 8 meters per second, and then plus negative 9.8, and then times the time. What is the time? I think the time is just simply 4 seconds there. So it took 4 seconds, right? It's going to be the final velocity. It's going to be negative 31.2 meters per second, right? So this is negative because we took the downward direction as negative, right? Or we took the upward direction as positive, basically. So it means that this is going to give us a 31 point, that which indicates that it's going downwards, right? So this is the velocity that it hits the ground with here. It hits the balcony with, right? So that's like the final velocity at the point, right? So the final velocity there, it's 31.2, right? So now let's move on to 3.2.2. They want us to now calculate the height of the balcony, right? We don't know the height of the balcony, but we are given the height of the building, and the height of the building is 60 meters, right? So I think the smart approach here, it's because we have the initial velocity here, we should work out what is this displacement here, right? Should you work out this displacement here, you can see that the displacement there plus the height is equal to the 60 meters, right? So but how are we going to work out the displacement here? We will make use of these 2 points, because displacement, it is the final position minus the initial position, right? It's not the total distance covered by the ball going all the way up, and sort of by the object going all the way up and coming back there, right? The displacement is basically the change in position, right? So we consider the starting position and the ending position of the object, right, to work out the displacement, right? So that would have given us the distance from this point to the balcony, right, from the highest point of the building to the balcony, right, which is this point here to the balcony, right, which would have helped us to calculate the actual height, right? So let's get straight into that question. So to calculate the height h of the balcony above the ground, because we have the initial velocity here, we can make use of the initial velocity. It's 8 meters per second, and I think we can select a formula that is suitable for that. So we also have the time, right? If you take a look at it, we also have the time, and the time is 4 seconds taken to reach the balcony, right, from that initial velocity. So now we can check the delta y. So the delta y, it's going to be vi delta t plus half a delta t squared, right? So we can make use of this formula to calculate the delta y, right? So what is the initial velocity? We're taking upward as positive and downwards as negative. So it means that the acceleration is going to be negative, right? So this is going to give us 8 for the vi, and the delta t is going to be 4 seconds plus 1 over 2. What is the acceleration? Negative 9.8. And what is the delta t? It's still 4 seconds. Then we square that. So if we do that, we will see that the delta y here, it's going to give us the answer being 46.4 meters, right? So this is the displacement from the highest position of the building, from the highest point of the building, which is the initial position, and the final position, which is the balcony, right? So we worked out the height between those two, which is the one in red on the diagram there, right? The delta y, right? And I think if we've worked out that one, we can simply work out the delta y very simple by saying that the delta y plus the height, they sum up to the 60 meters, right? So the delta y, it's 46.4 meters plus the h, 60 meters. Then we can transpose this that side. Then you'll see that the h is equal to 60 meters minus 46.4 meters, which I think it's going to give you 13.4 meters. So let's just double check that. If we say 60 minus 46.4, we get 13.6 meters, right? So I think that would have been our answer there, right? Let's just double check that delta y if it's correct. You would have said it's half a negative 9.84 squared, right? And I think yes, it would have given you a negative delta y, and that delta y, we would have said, because it's going down, then this would mean that it's going downwards, right? Remember, displacement is a vector quantity, right? So all these we're dealing with here are vectors, right? So you'll see that the velocity is a vector and acceleration is a vector, right? Displacement is also a vector, right? Good. Okay, now let's get straight into the last question, where it involves sketching the graph, right? So I know that this is a section where most students find a little bit challenging, right? I don't know why, but let's try to get straight into it, right? So now, if you pay attention to this, we have the initial velocity that the object started moving with, which is 8 meters per second, and then we have the velocity for it to hit the balcony, which was 31.2. So the velocity that it hits the balcony here, which is the final velocity here for the balcony, it's 31.2 meters per second, right? So I think on the statement here, they're saying that the object bounces off the balcony at a velocity of this much, right, and strikes the ground 6 seconds after leaving the balcony, right? So it means that the moment it leaves the balcony, at some initial velocity, which is 27.13, right, to go all the way up and hit the ground after 6 seconds, right? So let's go and now sketch a velocity time graph, right? So to sketch a velocity time graph, okay, so we know that we'll just draw this, right, which is a straight line which represents our y-axis and our x-axis here. So this is going to be velocity v, and the time is going to be in seconds, right? So now let's indicate some of the values we have here, right, especially for the velocity, right, and the time. So we have the initial velocity, which we can say it's 8 here, and we can say it's minus 8 here, right? So here we have another velocity which is 31.2, right? 31.2, we can put it up there, right? And we can also put 31.2 just below this. It's negative 31.2, right? So do we have another velocity? I think we do have another velocity, and it was the 27, right? So this one we can put it here in the middle between the numbers, right? So 27.13, and we can also put minus 27.13 here, right? So this is the velocity, and we have 0 here. The velocity is 0 there, and this is v, right? V is in meters per second. So this is the velocity versus time graph, right? So the velocity versus time graph, you will see in this video how we would draw it. We draw it using the lines, right? So we want to take upward direction as positive, right? So if we take in the upward direction as positive, then it means that the motion going up here on this situation, we see that the object is going to go up until it reaches the maximum height, which the velocity is 0. But what happens to the object as it goes up? I think what technically happens if the object started with some velocity 8, what's happening there is that the velocity is decreasing as the ball goes up, as the object goes up to reach the maximum height. So as it decreases, we will show with the straight line touching that. So this point here, it's the maximum height there, right? So let's go and show that part, that first part there of the motion. So we'll take this and show that the object is going to reach the maximum height at this time, right? So this is the time it reaches the maximum height. We're not so sure about what time, what is that time, but we know that it's going to have the velocity as 0 at the maximum height, right? So that's the first thing we've drawn there. So this shows the upward motion. So if we're taking up as positive, then the upward motion must be above this point, must be indicated here, right? So this would be upward motion. So all the upward motions are going to be indicated by the lines that are drawn above, right? So we can see that as the time increases here, the velocity does what? It decreases, right? You can see drops there. The line is dropping until this point, which is representing the maximum height, right? So let's go and analyze there. So the motion, there's another motion here of the situation where the ball is actually going down, right? So this part where it goes down until it hits the ground as at this velocity, and it was a negative velocity, right, when we looked at it. So it means that you will now indicate with a line that the object is gonna continue to go in that direction, right? So you're showing the downward motion below, right? So this is the downward motion there. Let's look at it. The downward motion must be until the point, must be until this point, right? Must be until this velocity here. So we can see that the moment it gets there, it hits the ground, right? So it is in contact with the ground for some couple of minutes, right? Just before it does it moves up, right? So we can see that all the way from this point to this point, this was the maximum height, and continuously going down. So this here, it's indicating the downward motion, right? If we see a line there, it means that that's a downward motion according to our key, right? Downward motion, it's going to be found below, right? It's going to be found below that line, that straight line, that horizontal line, right? Which is the x-axis, right? Okay, so now because we are just about to witness the vertical motion of the object, because look at it here, it's just gonna hit the balcony at that 31 point, and it's negative because it's going down, right? So as it hits that, now the object is gonna go up, right? So let's just indicate that. Let me draw that properly. So the part in red, you will see that here it's just the motion of the object while going down, and it's gonna hit the ground and move up, right? So as it moves up, we will see that it will reach the maximum height again, once again, right? And the moment it reaches the maximum height, it's sort of like a turning point because it changes the motion, and it shows us the motion going down, right? So now let's show this motion going up. So now we're just gonna draw some dotted lines there going up on our graph. So this graph here, we're going to show some dotted lines going up there, right? And then we will do that until 27, right? We'll do that until 27 because we just want to indicate the part where the graph was in contact with the ground. So this part here in red, what I'm showing in red, it was the just some moment when the ball was in contact with the ground, right? So again, now you will see that the moment it hits it leaves the ground, it's going to show an upward motion, and I said the upward motion, you will see it being above the line, right? So this is your upward motion again, right, until it reaches the maximum height at this point. So when it reaches the maximum height there, you will see that it will continue to go down. So now let's indicate the times, right? I think we're supposed to consider the time. So the time taken to hit the ground, it's supposed to be this one here. It's 4 seconds. So it hit the balcony, it's 4 seconds, right? Let's take a look at it there. That's the time taken to hit the balcony, right? It's 4 seconds there, corresponding to this velocity, right? And then now we'll see the upward motion there. Now this is the maximum height. So what is this point here? This point, it's the second maximum height, which is this point over there. And now we are just about to witness the downward motion again. And remember, the downward motion, it's the one in red. So the downward motion here would mean that the ball is just gonna go down, right? So let's check here on the checklist, like the instructions here for the things that we have to include on our velocity time graph, right? They said they want to see the initial velocity, right? I think we've indicated that the initial velocity is this, right? The velocity at which the object strikes the balcony, we've seen that it's this negative 31.2. So it's negative because it's going down as it hits the balcony, right? So that's why it's negative there, right? So the time the object strikes the balcony, it's already indicated there, right? We've indicated this, and we've indicated the 8, and we've indicated the time, right? What else? The velocity at which it bounces off, we've also indicated it. It's there, right? The velocity that it leaves, the velocity at which the object strikes the balcony, we've indicated it, and the velocity that it bounces off, we've indicated it. So the time when the object strikes the ground, right? So that is a critical time there we have to include as well on this. But remember, the 6 seconds that we were given was the time taken to move from the balcony all the way to hit that, right? This 6 seconds here. So how can we show the 60 seconds? We have to say, we can't just write 6 seconds here, because 6 seconds, it is the change in time from hitting the balcony and going to the ground, right? So what we should do there with that time is we should say it's 4, right, plus 6. So it's 4 plus 6 here on the side, which gives us 10. And it means that the time here at this point, it's going to be 10, right? Okay, sorry about that. It's not supposed to be exactly at that point, because this is the maximum height time, right? So we should just show the downward motion once again, right, which we don't know where the graph is going to hit that, right? But it's somewhere, it's something that's just gonna look like that. And then this time here, it is the time that we should include there, which is going to be 10 seconds, right? So that's like the total time taken from this point to, it's what should be recorded there, right? Not the time taken to move from hitting the balcony to the point, right? So I think that's perfectly fine there, right, with it. And I hope you'll be able to draw the graphs, right? It's not that complicated. You just need to obviously do the correct calculations here, of course, right, and have some imagination of these illustrations I was making here to explain this, right, showing you the upward motion and the downward motion, right? So if we take a look at it here with colors, so the green here, part in green here, would show the upward motion. So this would show the upward motion, right? And the part in red, which is this one, would show the downward motion, right? So never mind the red in and then the red part is just gonna show the downward motion, right? So this is in contact with the ground. Those dotted lines moving up there indicates in contact with the ground. And then now this part in green again is the upward motion, right? And the part in red again, we'll see the downward motion of the object, right? And then that's all until it hits the ground at some velocity that they didn't want to know, they didn't want us to indicate, right? So that's all that they wanted us to indicate there. So we are usually guided as we draw the graphs, right? So you will see the last picture there. So we've got one green part and we've got two green parts showing that the object is going up, right? And here we've got two green parts here showing that the object is going up, and two red parts showing that the object is going down, and also here on the graph, right? So please have a picture of this and do it again yourself, and you will see that you will make sense out of this thing, right? Let's now move on to the other part of the question, to the other question. So question 3 here, right? We're having a question here. Okay, we'll not be able to move this. Okay, let's work now. So question 3, the position time graph for a ball thrown vertically upwards from the top of a 48 tall building, right? So we see that here, that we given the position time graph, right, for a ball that is thrown vertically downwards from the top of a 48-meter tall building, right? So the graph is not drawn to scale, right? The ball bounces off the ground. So we can see that if we read this and we consider also the thing that's drawn here, we will see that it explains what's happening to the graph, right? on the statement. So the statement explains what's happening to the graph, right? So let's see that. So this is a position time graph. So the position time graph is different from the velocity time graph because now it's indicated by the trajectory, right? It's sort of like it's parabolic, right? You'd see a parabola graph drawn there, something like that, right? So okay, it's fine. Now calculate the speed at which the ball is thrown downwards. So by the looks of things here, we are given the displacement, right? And remember, the displacement is a vector quantity, right? So because we have the displacement here, we can say the displacement is equal to 48, right? And we have the time to hit the ground, right? I think we can also make use of that. The time taken to hit the ground is 2.8 seconds, 8 meters, right? And then they want us to calculate the initial velocity of that, right? So if you take a look at your formula sheet, you will see that there's a formula delta y vi plus vi delta t plus half a delta t squared, right? So now if we are taking upward as positive, it means downward would be negative in that case. So we would see that the delta y is going to be negative, right? Because it's going down. The displacement, the motion of the object, it's downwards, right? So the negative, the 48 is going to be negative here. And the vi is what we are calculating, which is the initial velocity at the point. We didn't have it this time around. So it's vi. What is delta t? It's going to be 2.8 seconds. Remember, time is a scalar quantity. We don't have to indicate the direction, right? And remember again, the acceleration we said is 9.8 downwards. So it's going to be negative 9.8, right? So what is the time? 2.8 seconds, right? So if you do all the necessary calculations here, you'd see that you'll get this. And then on the right hand side, let's just check quickly the answer. Negative 9.8 and then 2.8 squared, right? You would have gotten that the answer is negative 38.416 on the right hand side, and you will transpose that side, right? If you transpose that, it's going to be negative 48, which is equal to 2.8 vi. So let's go down. You would have seen that you are going to add those plus 38.416 equal to 2.8 vi. So it's going to be negative 48 plus your answer, which gives you negative 9.584, right? And then 2.8 vi. Divide both sides by 2.8. You'd see that the vi is going to give us a negative answer. It's going to give us negative 3.42 meters per second, right? So it means that the vi here is 3.42 meters per second. It mainly means downwards, right? So because of our direction key, right? The key that we took here, we said that we're taking negative as we're taking upward as positive. So what we see as negative on our answers, so all the vector quantities are going to be substituted as negative into the formula, like you see the delta y and the acceleration. Even the velocity, we can see that it's giving us a negative answer, meaning that we took, meaning that the velocity it's going downwards, right? Let's calculate 3.1.2. So 3.1.2 here, calculate the velocity that it's gonna hit the ground, right? We now already have the vi, and the vi is what? It's 3.42 meters per second, and it's going downwards, right? Remember, so it's that velocity there. We have 3.42 meters per second, right? So what is the final velocity here? at this point, we don't have it. So we're looking for the final velocity there, and I think we can calculate it, right? We can find a suitable formula. If you look at your formula sheet there, you will see that the delta t, you'll see that Vf is equal to Vi, because we have the time, because the time is 2.8 seconds. And what else do we have there on the graph? We do have the displacement, right? But I think this formula would have been a suitable formula to use for that situation. Velocity there. So the final velocity in this case is going to be the Vi here, which is a negative 3.42. Remember, we're still sticking to our direction. We're taking upward as positive and downward as negative, right? So it's going to be negative 3.42 plus the negative acceleration, which is negative 9.8, and the time it's going to be 2.8. So if you select the direction, you must stick to that direction and throughout the calculations, right? Just to be consistent, right? And pay attention to direction in this topic because it matters. You are dealing with vector quantities, right? So this is going to be negative 9.8 times 2.8, right? And I think the answer there is going to give you a negative answer, right? So the final velocity here is going to be negative 30.86, right? 86 meters per second. So what is the final velocity? The final velocity is 30.86 meters per second, and then downwards. Right? So the negative there indicates that the velocity is going downwards, and I think it makes sense. Think about it. I mean, if the velocity here it's 3.42, what is happening to the velocity as the ball goes down? If it's vertically projected downwards, the velocity is increasing. Do you see that? It's increasing, and we will hopefully see that. Why did I write 0 here? It's a mistake. Sorry about that. So the final velocity is not 0. I meant a question mark there. So your final velocity here, it's just gonna be that answer we got, 30.86, right? So it makes sense to have such a huge number for the velocity that it's gonna hit the ground with, because remember, it's coming all the way up there from a height of 48 meters, right, to hit the ground, right? So that's the velocity that's going to hit the ground with, right? So they say now they want us to calculate the velocity that it's going to bounce off with, right? So this is a very a practical situation, because if you think about it, you have the velocity that it hits, and the velocity that it hits the ground with, it's not actually the velocity that it leaves the ground with, right? So we can take this one as our final velocity, right, the maximum height here, and we can take our initial velocity as the velocity that it leaves the ground with, right, and make use of the delta y, which is the change in position, right, 8 meters, right? So we can see that this 8 meters, the motion of the object, it's an upward motion. So we'll say for 3.1.3, you will see that we'll be having the initial velocity, which is an unknown, which is what we're trying to calculate, and the final velocity is 0. We'll make use of the delta y, which is 8 meters, right? So we're taking upward direction as positive and the downward direction as negative, right? So what is our answer here? What is our goal? Our goal is to calculate the velocity that it leaves the ground with, right? So I think you can make use of this formula. Vf squared is equal to, if you take a look at the formula sheet, you will see that you have the formula here. Vf squared is equal to Vi squared 2a delta y, right? So what is your Vf? It's 0 squared, right? What is your Vi? It's the unknown. What is your acceleration? It's negative 9.8 because of the direction, right? What is the delta y? It's a positive this time around, the delta y, because the motion of the object is going up. Remember, displacement, it's a vector quantity. You can see by this time around, when we want to calculate the initial velocity here, the final velocity is actually 0, but because the displacement is going up, we take it as positive, we say it's positive, right? Because we took the upward motion as positive, right? So you will see that here it will just be a very simple question to solve here, because you will get a negative answer here. Say vi squared, this is 0, so 2 times negative 9.8 times 8, it's going to give you a negative 156.8, sorry, transpose, and then 156.8, and then it's equal to vi squared. Introduce the square root, guys, don't forget the square root, and then you'll see that the vi here, it's just gonna be the square root of the answer. It's just gonna be the square root of 156.8. And I think your answer there for the initial velocity, which is the velocity that it's going to leave the ground with, it's this. This is the actual answer. So usually if the ball hits the ground at some velocity, that velocity is not the same velocity that it's going to leave the ground with, right? So if it hits the ground with some velocity 30.86, it's probably going to leave the ground at a different velocity. So we had to calculate it, but usually we would use the maximum height, because we know that the maximum height's velocity is 0. So we will use that and use the initial velocity with the displacement, right? In this case, like in this situation, because we knew the displacement, right? So I think that's perfectly fine there. And I would think I will just have to just erase this part here, right? We will note down that the velocity that it hits, it's that, right? I just need a space to be able to draw the graph, right? So to draw the graph, of course, we will draw a straight line here like before, right? And draw another straight line here, shows the x-axis, right? So here they want us to draw a velocity time graph, right? Not to scale, just for the entire motion of the ball, right? So we have to indicate the initial velocity, right? So what is the initial velocity of the ball? I think we had calculated it. It was 3.42, right? So that was 3.42, and we'll show this one negative 3.42. So what else do we have? We had the we have 15 here. So we have 12.52. So let's show this 12.52 on either side. So 12.52 here and a negative 12.52 here, right? So I'll erase this. We just need some space here, and I think we can also indicate the other one. It was 30.86. Remember, this is the velocity that it hits the ground with, right? So indicate it in both sides, your negative and your positive, right? So it's that 86, right? So now let's check here, right? Where did the ball start? I think it started at, we're taking upward as positive, right? So it means that the upward motion, it's going to be above, right? So this is going to be upward motion of the ball, right? Good. But now remember, the ball did not start, it's not going up. So I'm not gonna start here like I did with that previous question, but I'm just instead gonna start somewhere here, right? But what is happening to the ball? What is happening to the ball? Is it moving towards the maximum height? No, if you take a look at it, I mean, it's going towards down. Let's take a look at the position, its position time graph. It's going down, right? And if it's going down, the velocity is increasing, right? It's increasing in such a way that it hits the ground at this 30.86, right? And remember, this one was also negative, so we can just show a line from all the way from this point to the 36.6. So this is showing the velocity of the ball. So this is the part where it's gonna hit the ground, and when it hits the ground, we can record the time here What is the time the ball hits the ground? I think it was 2.8. We can also look at it from here, right? That was 2.8. Let me just use green color here, white color maybe, it's better. 2.8, yes. And then let's also indicate the upward motion. So this is the time when the ball was in contact with the ground. So it was just in contact with the ground for that. Should just indicate the dotted lines all the way up, right? So what is the velocity that it's going to leave? So to leave the ground, remember this is the hitting velocity. It's going to hit the ground with this. So it starts with this. This is the VI. This is the velocity it hits the ground. Do you see that? And the velocity that it leaves, it's somewhere here, which is that 12.52, which was calculated there, right? So we can show this with the upward motion, but you can see that as it does the upward motion, this upward motion here, it's just until some maximum height somewhere, right? So I'll just erase this. So show the part where it's going down in red, right? Going down in red and going up, it's gonna be the green, right? So that we are a little bit consistent there, right? So to just be consistent with this, you will see that the part in green here will be showing the upward motion, right? So it means that here it's until it reaches the maximum height and where the velocity is 0. So remember, reaching the maximum height here, it's going to be, but it's going to be a 0 at the maximum height, right? So you can see that as the ball leaves the ground with 12, so the ball is going to leave the ground with 12.52. It decreases its velocity until it reaches 0, right? So the decrease now will be accounted for by a line that is just going to be a decreasing line, right, until some time there, right? So what is this time here? This is the time reaches the maximum height, right? So I think we've shown the initial velocity on the checkpoint here, on the checklist or on the instructions, right? So the velocity with which the ball hits, I think I did indicate that. The time taken to attain this velocity, meaning the hitting, time taken to hit, we saw that. And now the velocity with which the ball bounces off the ground, right, until it reaches the maximum height. So we can see that here we just have one red line, right, which indicates that the ball is going downwards. So this part here is the part where it shows the downward motion, right? And the part above, the horizontal line, it just shows below, right? So they needed only one time here. That's why I only indicated only that time. And I think you guys are learning a lot from this video when it comes to drawing. I might be taking too long, but I'm just trying to emphasize the importance and how and the steps that you should take in drawing these graphs, right? But should you watch this a couple of times and try to think about it, it's definitely gonna make sense. I don't think I will be able to cover this problem necessarily, and I think with this video I'm just gonna end it here, and I think that's perfectly